Morning, everybody. I hope you're having a great day so far, but if not, this is going to be the time that you are going to get real excited. We're going to be talking about three-dimensional shapes today. We're rolling into our last chapter here on surface area and volume, but before we tackle that, we are going to be looking at 3D shapes, some vocabulary. So we're going to start off with our first word is polyhedron. So one thing we know for sure is it's going to be three-dimensional, and we know that because that's the title of our notes. So let's look at these three shapes. These three shapes right here are polyhedron. This first one is a square pyramid. This guy right here is a rectangular prism. And this third one down here is a triangular pyramid. Now, these three shapes are polyhedron, but these three shapes, the sphere, the cone, and the cylinder, are not polyhedron. So what do you notice about the two? What do you notice about these two groups that makes them different? Well, all polyhedron, not only are they three-dimensional shapes, I mean, these guys are three-dimensional shapes, right? But all polyhedron are made up of polygons only. So if you remember from our polygon chapter, polygons are going to be like rectangles, triangles, pentagons. They are going to be shapes that have no openings, that have no crossovers, and have no curved edges. So you can see that all of these shapes are polygons. So 3D shape made up of only polygons. All right, so what makes these not polyhedron is that these are made of non-polygon. So you can see that the cone has a circle in it, the cylinder has circles in it, the sphere is just like a curved shape. So in order for it to be a polyhedron, it has to be made of only flat surfaces, right? So rectangles are flat, triangles are flat, so no curved bits at all. Okay, so these are not made of polygons, only polygons. All right, so let's talk about a couple vocabulary words that go with these. Now, a face, an edge, and a vertex can apply to both of these sets of shapes, polyhedrons and non-polyhedrons, so they don't just belong to one set. So a face is the flat surface that makes up the three-dimensional shape. Flat surface that makes up the 3D shape. All right, so if we think about the square pyramid, how many flat surfaces make up our square pyramid? Well, we've got the 4 triangles on the outside, right? And then we have the square on the bottom. So 4 triangles, 1 square. So the square pyramid has 5 faces. A rectangular prism. How many faces does a rectangular prism have? Well, it's got the front and the back, so that's 2. The left and the right, so that's 2 more. And then the top and the bottom, which would give us a total of 6 faces. All right, what about the triangular pyramid? Well, we've got the 3 triangles going around plus the 1 triangle in the bottom, so there are 4 faces. So this guy had 5 faces, this one had 6 faces, and this one has 4 faces. So just those flat surfaces that are making up the three-dimensional shape. All right, edges are the segments where 2 faces meet. All right, so edges are the segments where the 2 faces meet. Okay, so let's talk about the square pyramid again. So how many edges are there? Well, there's a segment in between those 2, a segment in between those 2, a segment in between those 2, a segment here. All right, so we're at 4 so far, but then we have this one, this one, this one, and this one. So that's 4 more. So we have 8 edges. All right, what about the rectangular prism? So we've got 1, 2, 3, 4. But then we have these 4 on the top, 5, 6, 7, 8. And then these on the bottom, 9, 10, 11, 12. So we have 12 edges. All right, give this one a go. How many edges do you think our triangular pyramid has? So we have 3 going around, 1, 2, 3. We have 3 along the bottom, so we have 6 edges. All right, our last vocab word then is a vertex. A vertex is a point where 2 or more edges meet. So basically it's the corners of your shape. So point where 2 or more edges meet. All right, so in a square pyramid, we've got this vertex plus 1, 2, 3, 4, these 4 corners at the bottom. If all we're doing is looking for corners, let's try that again. So this has 1, 2, 3, 4, 5 vertices. So that's just the plural of vertex, vertices. So how many does this guy have? We've got 4 on the top, 4 on the bottom, so we have 8. And then our last one, triangular pyramid, 3 around the bottom plus the 1 guy at the top, so it has 4 vertices. Awesome. All right, so we've got those vocabulary words out of the way. Now let's talk about very specific 3-dimensional shapes. So we're going to start out with a prism. So a prism, first of all, is a polyhedron. Okay, these are all prisms. Do you notice anything about them? Well, they have at least one set of congruent and parallel sides. So this guy right here, the congruent parallel sides are those 2 triangles. And in this one down here, the congruent and parallel sides would be those 2 pentagons, because there's 5 sides to each one of those. Now, in this rectangular prism, though, there are lots of congruent and parallel sides because everything there is a rectangle. So the top and the bottom, the left and the right, the front and the back, those are all congruent and parallel. So it's going to be a polyhedron that has at least 2 parallel and congruent sides. Now, those congruent and parallel sides are called the bases. So in this guy right here, this guy and this guy would be our bases. In this one, this would be a base, and this would be a base. Now, in a rectangular prism where everything's a rectangle, it could be the top and the bottom, it could be the front and the back, it could be the left and the right, because all of those sets are parallel and congruent. Now, when you name a prism, you always name it by its base. So here our bases are triangles, so this is a triangular prism. So always named by the base. This would be a rectangular prism. All of the sides are rectangles. And this is a pentagonal prism or a pentagonal prism, however you want to say it. Pentagonal prism, because the pentagons are the bases. All right, so those are prisms. Now, what in the real world are prisms? Kleenex boxes, cereal boxes, really any kind of box. I don't know if you've ever seen the candy bar called Toblerone, but it comes in this triangular prism box. You should Google it, take a look at it. So look around your house, see if you can find any other types of prisms. All right, let's talk about our next shape. That's a pyramid. Is a pyramid a polyhedron? Yes, because pyramids are only made of polygons. So a pyramid, though, is different than a prism because you can see in a prism we have two sides that are parallel and congruent. We have two bases, right? And here we have two triangles that are bases. Here we'll have two rectangles that are bases. Here we'll have two pentagons that are bases. But in a pyramid, it only has one base. So it's a polyhedron. With only one base. All other sides or faces, right? Those are faces, are triangles. And they will intersect, all of those faces intersect at a vertex. So you can see here, we have all triangles in this picture. So similar to a prism, a pyramid is named by its base. Well, since every side is a triangle, this would be a triangular pyramid. In this picture, what do you think the base is? It's this guy here on the bottom. So here, any of these sides, any side is the base because everything's a triangle. In every other kind of pyramid, the base is always the non-triangular side. All right, so this we could call, if we knew this was a square, maybe this is a square pyramid. If we didn't know it was a square, we could call it a rectangular pyramid. All right, so what do you think we would call this one? Well, this guy here on the bottom is our base because it's the non-triangle. And it has 1, 2, 3, 4, 5 sides, so pentagonal pyramid. All right, the next three shapes are not polyhedron. Our next three shapes have curved edges, so our cylinder, our cone, and our sphere. So cylinder is not a polyhedron. Because it's made of circles. So we can clearly see that the top and the bottom are circles. Do you know what the middle part is made of? Have you ever taken the label off of a can of soup or a can of beans? The middle is actually a rectangle that's been rolled up. If you don't believe me, take a piece of paper, roll it up. What shape does it make? It makes a cylinder. So this right here, when you draw it separate, this is called its net. The net is just all of the shapes that it's made up of. So this is called the net. All shapes it's made of. And a net is always connected. You don't like draw all the shapes separately. All right, so in a cylinder, it's actually a lot like a prism. It's just curved. So it's going to have two parallel and congruent circles for bases instead of instead of polygons. And then the middle is a rolled up rectangle. All right, a cone, also not a polyhedron because the base is a circle, but this is a lot like a pyramid, right? It's just the bottom isn't a polyhedron, or sorry, a polygon. So if this is like a pyramid, but it's not a polyhedron. All right, so it has one circle as its base. Now this is the crazy part. Have you ever been to, well, you probably have never like undid a birthday hat, but if you unroll a birthday hat, it's actually a section of a circle. It's called a sector. Oh wait, we talked about sectors. So if you unroll a birthday hat, it's actually going to look a lot like that. So this would be the net. So this would be your base, and this is the rolled up sector part. So the rest of it is a rolled up sector. It's kind of crazy. All right, our last one is a sphere, and a sphere is also not a polyhedron. A sphere has no edges, it has no vertices, it has no faces really. I guess the stuff around the outside could be called its face. But what makes a sphere is very similar to what makes a circle a circle. Do you remember in a circle is made up of all points that are the same distance away from the center, right? The same thing is true in a sphere, it's just three-dimensional. So instead of just going left and right, we can also come out and down and toward you. Like, it's kind of crazy. So it's not a polyhedron, but it's a 3D shape that has all points equidistant, same distance from the center. All right, so that wraps it up for our introduction to three-dimensional shapes. We're going to be getting after prisms in our next couple lessons, finding the surface area and the volume. As always, if you have any questions, please give me a shout out. Otherwise, have a fantastic day.